Hi there, my name is Chancellor Swalimsipa. Welcome to this presentation of multiplication of matrices. I'd like to start from where we started looking at introduction of matrices. You recall that we introduced the matrices in the following manner by looking at a price list of two articles, in this case, which were pencils and colored pencils costing price of X and Y. We saw that the problem actually took us to these types of equations, which we called simultaneous linear equations. In this case, two equations with two unknowns. Now, this we summarized it as follows: that we end up with a system of linear equations, and focusing on different entities, we saw that we could only look at the coefficients there in the order in which they come, and create a matrix like this, which we called the matrix of coefficients here, and give it name C. X and Y were the prices. Then we call that matrix P, and the independent right hand side independent terms were the totals which costed each individually. Who was shopping, which was 26 and 19, and then we talked about type of matrices. And then in this now what I want to talk to is to talk about multiplication. As we noted before, that addition, we need to be careful when we do it. Remember, I said we add matrices of the same type. And now coming to multiplication, we actually need to be more careful. We mentioned that. But however, in the way we introduce the matrices, we actually note that in this kind of setup, the matrix multiplication is already suggested by looking at this C, matrix of coefficients, as a coefficient of this matrix of unknowns equals to the right hand side here. We get a kind or a type of equation which is very similar to the equation 2x equals to 8, which most of us are familiar with. Now, why am I saying that matrix multiplication is suggested here? Because what we did to get here actually to rearrange this information given this way. Now, if you look at how it was rearranged to this form, already the multiplication of matrices is suggested here, because you can see that they've got 2x plus 4y, which x and y, which are the entries of this column matrix here. So then we take it as a known, then we quote it this way. So what is important to note is that looking at the types of these matrices which are involved here, this one is a 2 by 2. In this case, I'm talking about C, is a 2 by 2 matrix, and the matrix of the unknowns here, which is X, is a 2 by 1. And at the same time here, when you multiply here, I think you can see from there that what the matrix we get here is actually also a 2 by 1. So also something else which is suggested here, which is obvious, is the quality of matrices. Like we have here 2x plus 4 equals 26, and 3x plus 2y is equal to 19. So if I handle this as a matrix of this type, 2 by 1, then I will collapse these two cosines to 1, and that will mean exactly what we had before. We put the brackets, that this entry is equal to that, and that entry is equal to that. So that is just some kind of bonus information you can learn from here because of this setup. So now coming back to multiplication of matrices, so already we can see that these matrices can be multiplied and they give us this. So whenever we're going to multiply matrices, it will be very important to look at the types of the matrices, and at the beginning like this, you might need to put the types this way in the order which you're multiplying matrices. In this case, it's C and the X, and then you've got to focus your attention on these two entries here, or you know that these are number of columns in the second matrix, and these are number of rows. So we'll always be able to multiply two matrices if the number of columns on the matrix or in the matrix on the left is equal to the number of rows of the matrix on the right. So as it is here, it means we see that 2 is equal to 2, and then that tells us that we can multiply the two matrices. And if we multiply them, the two matrices are going to get something like this. So as you can see here, we have 2 equals to 2, meaning the number of columns in the matrix on the right is equal to the number of rows in the left, which means the multiplication can be carried out, and when we carry out that multiplication, we'll get a matrix like this, which in this case of order 2 by 1. So what you note here is that these two numbers, they tell you whether you can multiply or not, and these outer numbers give you the type of matrix you are going to get. Now, to see exactly how we multiply matrices, then we need to focus on what is happening here. What you can see is that this column has been actually changed to a row over this matrix. Then we multiply the matching entries, like here. If we rotate this column anti-clockwise, x is going to match 2 and y is going to match 4. Then we multiply like that and add. Then we let that row made of x and y here to go down to multiply here to get that. So that is how roughly we multiply matrices before we can that's roughly a comment we can make on how to multiply matrices. Then I think it will work now to look at examples. But first of all, we need to be able to know how to decide that we can multiply matrices. For example, if I were to take now this kind of multiplication xc, I would put here 2 by 1 and the 2 by 2. So now if I do that kind of reflection on these two numbers, we see that this cannot be done. So that tells you that in this case here, only this order of multiplication can be done, but the other cannot be done. And that is important also. If we've got matrices which are multiplying, it is possible that the two orders of multiplication can be done, A by B and B by A. And reflecting on multiplication of numbers, we know that if we 2 multiplied by 3, that equals to 2 to 3 multiplied by 2. But with matrices like this, these two matrices, even if they would multiply in any order, generally these products are not equal. Now let's turn to examples and see which matrices can be multiplied here. So we can take them 2 by 2 and decide whether we can multiply or not multiply. Then later we're going to look at how we can multiply. For example, if we do attempt to do A, B. So what we do, we'll take the type of A, write it down there as 3 by 3, 3 rows and 3 columns. And B will be 2 by 2. And here we can see that we've got a conflict there. These two are not equal. So this multiplication is not possible. So I think on your own you can continue doing this kind of checking which matrices can multiply. Now I'm going to take two matrices you can multiply and try to show you how to do it, this multiplication. So let's say we're to multiply A, D, because see that A and D are both 3 by 3. So then we have 3 by 3, 3 by 3, 3 by 3 matrix multiplied by 3 by 3. This is not suggesting that we can multiply matrices of the same order only, like we've seen in the previous system of linear equation. One was 2 by 2 and the other one was 2 by 1. So here it tells us that we can multiply. Now going on with our multiplication, we would write that multiplication exactly in the same order the names are coming up here. So that would be 0, 2, 8, minus 5, 7, 2, 1, 2, 1. The next matrix which follows 1 minus 4, 7, okay. Then here what we need to do now is to open a big bracket in this way. So what we first do here, you take this column, rotate it anti-clockwise, which you normally call, we transpose this column, make it a row, but anti-clockwise. So I'm going to have 0. I'll use a dot here for multiplication. Dot 1. So I was saying we're going to use dot here for multiplication. So multiply this 1 into 0. 0 times 1 plus 2 times 2 plus 8 times 6. So in that case here, we'll be having 1, 2, 6. Now, then we try to run that row down the matrix like this. In the next case, you're going to have minus 5 times 1 plus 7 times 2 plus 2 times 6. So you can see the way I'm writing here. I'm writing my entries in the multiplication here to actually indicating that 0 is coming from the matrix on the right, so is minus 5. That is just for organization so that I can see that I've almost captured all the elements correctly. So the next row here, we start with the 1 times 1 plus 2 times 2 plus 1 times 6. So now at that point we've finished with this row, multiplying there. So we'll do the same thing with this row. Now with the first row here, we made the with the first column here, we ran through downwards, making the first column. Now to make the second column, we have to come with this one and do exactly the same thing. I hope you can see that minus 0 will match minus 4. Then you write that way, plus 2 times 0 plus 8 times 8. And then next we have got minus 5 times minus 4 and plus 7 times 0 plus 2 times 8. And next here we're going to, the last entry will be 1 times 1 plus 2 times 0 plus 1 times 8. Then lastly, the last row, we're going to have 0 times 7 plus 2 times minus 3 plus 8 times 5. So the next entry here would be minus 5 times 7 plus 7 times minus 3 plus 2 times 5. And lastly, we've got here 1 times 7 plus 2 times minus 3 plus 1 times 5. Now as you can see, now this is going to give us 1, 2, 3 rows and 1, 2, 3 columns. So then what is left now is to do the arithmetic, multiply and simplify this and get a matrix in a simpler way. So that will take us to, we can now write smaller bracket here. Now what we've got here, we've got 0 there, we've got 4 there, and then we've got here 8 times 6, which will be 48, plus 4, which would be 52. I hope that is correct. You can double check my calculations there. Then this is 14 and 12. That would be 26 minus 5. That would be 21. Oh. Then this is 6 plus 4, 10, and 11. Then we've done with that. Coming this side, you put 0 and 0. Then you've got 64. Here you've got 16 plus 20, which will give us 36. Then we've got 8 times 8 times 1 plus 1, which will give us 9 there. And lastly, I'll leave this one, this simplification to do it yourself. I'll leave them say complete there. But after this example, I hope you've noted exactly how you carry out multiplication. Otherwise, after completing this, you can take several examples from the collection of exercises you've got here and do all the possible multiplications. So others for now, I would like to say thank you for listening.